Hello everyone. Today we are going to study about inter-integrated circuits. So inter-integrated circuits are also called as I2C or I2C or IAC by many people. So I2C or I2C stands for inter-integrated circuit. That is basically a protocol, and that was invented by Philips Semiconductors and in 1982, and it is now widely used for short distance communication. Like you can find that in the market multiple sensors are available, or in case when Arduino didn't have the capability of ESP32 or ESP8266, that time to connect Arduino and send data through, Arduino UNO, to send data through internet, we used to use I2C protocol only. But even now, multiple sensors like MAX 30102, MAX 30100, and different type of sensors works on I2C protocol. And how they want is they want to connect multiple devices, multiple microcontrollers in a single by using just two wires. Then in that case we use I2C protocol. It was used to connect CPU, the CPU of the TV, to the multiple peripheral devices and multiple peripheral input output components. For that purpose actually Philips designed this I2C protocol, but till now it is used widely everywhere all over the world. The main capabilities, by just using two wires, it can connect up to 1024 devices when they use 10-bit address. When they use 7-bit address, they can connect up to 128 devices at a time. So that is the main advantage of I2C protocol. So you can have a look here, like there is a master device, there is another master device, there is a slave device, and there is another slave device. So this master device can send any information to this slave device, and this master can send information to this slave device or any slave device that is actually possible. It depends, because master device always allots some address to slave devices. For example, these two slave devices are connected, so it wants to send any information to this. So for example, this slave device number is 9, this slave device number is 8. So when it wants to send the information to 9, then it will go only to 9. When it wants to send the information to 8, that time the information will go only to 8. So that is the logic. This slave devices also keeps checking whether the information is for it or it is for other devices. So when this device slave identifies, for example, its address is 8, so what it will do, it will just find it is for me. So it will receive the information and it will send the acknowledgement to the master. So in this protocol, acknowledgement goes always to master to be sure that okay, the data is received. So data transmission happens 9-bit process. It's a packet of 9 bits. And the start bit is actually 1 bit that we are not counting, but 8 data bits are there, and at last one more acknowledgement bits are there. So data bits plus acknowledgement bits, they are 9 in number. So that is the logic. So whatever I told you, that is actually available here. Master mode and slave modes are the two modes. In this, any device can be slave and any device can be mastered. It depends on the master device that what address you are assigning in that. Even in the slave devices also, it has to get information from which device, that also you have to. This is very important. The two lines are open drain, hence a pull-up resistor is required so that the lines are high, since the devices on the I2C bus are active low. So that basically what happens, we need to add the pull-up resistors so that only data will be connected. Because it's always high in the case. So just you should understand that we can use, if you want a very high data rate, then resistance value should be low. If you want slower data rate, then high amount of 10K resistors should be used, and for high speed you can use 2K resistors. So that is the logic. And this is the start condition. Start condition means 1 bit and slave means 8 bit and acknowledgement means 1 bit. So totally generally we are using this one. Slave address and acknowledgement will be giving you the 9 bit will be consumed. So this is the I2C protocol setup. In this we have used two microcontrollers, two Arduino UNOs. One is master and one is slave. This is master and another one is slave. If the slave can be a sensor as well. Like I told you, multiple sensors are there. Those work on different protocols. And even the display devices also, like LCD, also can be connected with I2C. And multiple devices are actually possible to be controlled. So this microcontroller is this is the master and this one is the slave one. So in the master, whenever we press the button, this slave gets the information that okay, one data is being transmitted from the master. So how many times I press this button, you will see that one LED is glowing here. So how we are using actually? We are using just two wires. This one is A4 and this is A5. So you know that in Arduino that A4 and A5 are the data and clock pins. So based on that only, this is the clock and this is data. So based on that only we are going to use this one. So in this case, that 5-volt supply we are giving to this one, and the same and the ground is connected with the ground. So you should understand this one in any microcontroller. I mean, you want to connect to two different microcontrollers, and you want to do any operation. In that case, if you want to connect through wire, then in that case ground should be always common. Then only the information passes correctly. Otherwise, the information won't pass unless it is a wireless setup. In a wired setup, you always need the common ground. So usually we say that the people have to come on common ground to understand the thing. That same goes with the microcontrollers as well. So when I press this button, the logic comes from here and goes to pin number 2. Okay, this button is being pressed. So this it will be known by the pin number 2 of master microcontroller. And then from this A4 and A5, this information will be passing. So you know the data pins and clock pins. Clock pins means when the clock is getting low, that time only data transmits as per I2C protocol I'm telling. So the same thing happens here, clock gets low and the data transmission takes place. So once the data transmission takes place, that time the slave device understands, okay, from that address, the address also is very important thing. You have to give the same address in both of them, then only they will understand. That slave will understand the data is coming from my desired master, and master also understands that I'm sending the information to the desired slave. So the same thing happens. So once the information comes here, then the LED glows because the logic is given in such a way. So we'll see that what is the program available inside master. You have to click on master and then you can go to code, then you can type or see the code available in master. When you click on this second microcontroller, you will see that the code changed because that is written there. So if you want to write or you want to change or you want to update anything, then you have to click on the microcontroller and then write the program. Then that process will take place. So first we will see the code of master. So in the master you can see that initially what we have to do. To initialize I2C protocol, we need to use wire.h header file, and in the slave address, this address is very important. If you change this address, it's not going to work because the slave address and master address should be same, then only it's going to work. So we are using the slave address as 9, right? And then if you have multiple devices, like for example, I have connected 3 or 4 Arduinos, then I'll be giving the address as 9, 8, 7, 6. And in the slave also at the same time, you have to give the same address. Like in one master, 3 addresses are assigned. In the slave also, 3 different slaves should be there with a number 7, with a number 8, with a number 9. So in whatever slave you are sending the information, that will go. So initially that state will be 0 and master send information will be 0. Now this is the void setup part of the code. In this we are going to start the I2C protocol. So wire begin is used. So wire pin should be the input pin. You know why? Because master is always sending the information. It's not receiving the information. So when we press the button, the information comes to the master that we have to send to the information to the slave. Then this is your serial begin. This is serial communication baud rate. Now this is the loop part of the code. This only runs multiple times. So with the delay of 50 milliseconds, this is just a safety. Like we have to give some amount of delay for the stable communication. Now digital read B pin. So what it will do? It will read the B pin. B pin means what? This pin. This pin is there, no? B pin is what? B pin is the input pin. So that B pin it will read. So after reading the B pin, it will just see whether what information is coming from the B pin. So we'll see what is B pin and how it works. So B pin is what? Digital pin 2. So once it is finding that if state of the B pin is high, it means it is pressed. Then what it will do? Master will send 1, digital logic 1. Where it will send? It will send it to slave. So using this one, A4 and A5, the clock and data will be sent. So once the information is sent, it will be considered okay. Then the process will go to slave. That we'll see later. Otherwise, if the master is not pressed, then the state will be 0. Rest now one sending information to slave, otherwise it will remain 0. Then wire being transmission in the slave address and master send and write end transmission. Like this is just the initialization that when the information is sent, it has to complete these processes after this. Okay, slave address, we are going to send the information to slave address, then master is sending the information and then it's ending the information. I mean ending the data transmission. So that we have to do. Now we'll see the code in slave. To enter the code of slave, we have just to click on the slave microcontroller. Then you can see. Now have a look. This is the slave part of the code. Here also I2C communication should be enabled. Then at the same time, it should have the same slave address. You change the address of master and slave, you see the information won't come. The protocol won't work. Then what is the L pin? L pin is the LED pin. We have connected pin number 3 to LED. So from our previous classes, you know that why this 220 ohm of resistor is there and why this LED is there and how they are connected. So we have connected that LED in pin number 3 so that we have declared pin number 3. So int receive is initially 0 and this is the setup part of the code. So when the wire begin happens, slave address it will match. Okay, slave address means from pin number 9 what information is coming. So that will be started. In our case, L pin is what? L pin is the LED pin. So LED pin actually is the output pin because microcontroller is giving the command to LED to glow. So that is the output pin. So on received, what information is received, that is actually checked by this line of code. So what is received? So void on received int x received wire.read. It will read what is coming from that one. If any information is coming or not coming. If any bit is coming is what? That we have to read from that I2C. Wire read means read I2C pin. What is coming? What data is coming? After receiving it will read. So that only here it receives and then here it reads. So once it is finding that if received information is 1, if it is 1, then what it has to do? It has to glow the LED. Otherwise, it has to keep the LED off. That is the logic. So now let us see the output. And try to zoom it as maximum as possible. See, whenever the button is pressed, the LED glows. But this button is not connected in slave microcontroller, right? It is connected in some other microcontroller. Then how it is controlling the information in the slave microcontroller? Because the same data is being received from this one and it's not, it's actually following the same command. So let us change the slave address and see what happens. If I change this slave address to 10, what will happen? In that case, you will see that now it's not working. Why it is not working? Because I have changed the slave address. So that is the overall process of I2C protocol. Now we'll see if the same address is given here also, then what happens? We'll just change this to same address. That was address I gave is 10. We'll start the simulation. And then we'll press the button and you see the same process again works. So address should be same. At the same time you can connect multiple microcontrollers and give different address, and at the same time you can connect with multiple sensors also. That also will work. So this is all about I2C protocol, and I hope you understand this one. So this is our another protocol that is called as SPI, Serial Peripheral Interface Protocol. That was basically developed by Motorola, and it's a synchronous serial communication protocol and works with the single master, single master and multiple slave architecture. Means you can see that there is only one master and that controls the multiple slave devices. So that is not having multiple master and multiple slave type of communication. That has only one microcontroller that controls multiple sensor, multiple devices. Actually, I have used this one before in a different type of RFIDs. Like RFID tags are there, RFID readers are there. So in that one type of RFID reader used to use MISO and MOSI type of structure. So that is one thing, and multiple sensors also use this type of communication protocol. So what is the main thing with this one is it has double amount of data transmission rate compared to I2C. You don't need to assign address to each devices. So those benefits actually it has. And it has full duplex communication, like communication can happen in both the direction at the same time. So it is used by a single microcontroller will be able to control sensors, ADCs, DACs, shift registers, SRAM, and others. So it has 4 wires. 4 wires means one will be having clock, one will be slave select, one is MOSI, and another is MISO. So what is MOSI, MISO, and slave select and clock? So when the clock pin is high, I mean when this is master and this is slave, in between these two, 4 wires are there, 4 communications are there. So you can see when the slave clock, I mean serial clock is active, that time only data transmission takes place. When slave select is low, it means this slave only we have to send the information. That time the data will be sent to this one. Then you can see MISO. In this, what is happening? The information is going from slave to master. It means slave is active. And in the case of, you can see that MOSI, that master is active and slave is waiting for the information to come. So in case of master out, slave in, means master active, slave inactive. And in the case of MISO, master in, slave out, means slave active and master is inactive. That is the condition. It's just waiting to receive. Active means it's sending, and inactive means it's actually receiving. So any number of data can be sent and received in between master and slave, and that the information will be very fast. When the master wants to send the data, it activates the MOSI line that I told you, that whatever is output, whatever is out, that is active. Out means active here. Now what is the main advantage and disadvantage compared to I2C protocol? So no start and stop bit. Means you remember in that one, start bit was there, then data transmission was happening, then acknowledgement was coming. So what happened? That is the main thing. So that there is no start bit. So data can be continuously be transmitted. But the main problem is acknowledgement is not coming in this case. So you don't get acknowledgement whether data received or not. So no complicated slave addressing system like I2C. You don't need to address every time that this device and this address like that. Higher data transmission rate, almost twice. Yeah, and separate MISO and MOSI lines, so the data can be sent and received at the same time. Full duplex communication will happen. Now the demerits are it uses 4 wire. Previously we were using just 2 wires, but here it has 2 wires. 4 wires. No acknowledgement, so you don't need the things. No forms of error checking like the parity bit in UART. You know that error correction and checking parity bits were there. No, those things are not actually allowed here. Only allows for a single master. Only one microcontroller will be controlling multiple devices. So in that case only we are going to use this one. So these are the information about the model of SPI and I2C. So with this, actually we tried to get the simulation, but what happened that SPI protocol is not accepted by this one, our Tinkercad. Because in Tinkercad, you remember that in I2C protocol we have written wire.h. Wire.h is actually activating the protocol for I2C. But here also in active real-time Arduino, if you want to use, that time you have to use SPI.h. It will activate the protocol of SPI. But in Tinkercad it's not supported. So we are not going to do the simulation for this one. But at the same time we are going to have, I'll show you how it should work. So in this also we should have taken this one master and one slave, and in this master and slave what we had to do, we had to give one serial clock line, one data line, and one MISO and one MOSI, clock, SS, slave select, and one MISO and MOSI. So one more thing you have to understand, in every microcontroller, MOSI, like you remember that a clock pin and data pin in I2C protocol were A4 and A5 in Arduino. Same way in different microcontrollers, it's always the same pin we have to use. It means for every microcontroller architecture, serial clock and serial data pins are defined. For Arduino UNO, it's A4 and A5. And different microcontrollers, the number will be different. You have to identify which is the serial clock pin and which is the serial data pin. Same way, in every microcontroller, MOSI and MISO pins are actually defined. You cannot use anyone as, you cannot make like we use for digital pins. We make any one input or any pin as output, but that is not possible here. In MISO and MOSI, you have to first declare, the declaration is already inbuilt. You have to always know that which pin is MISO and which pin is MOSI. So those you can just read that architecture, design and details of the microcontroller, you will understand about that. Thank you.
Don't forget to like this video and also subscribe to my channel.